Hello and welcome you all. Today we are doing next topic of our chapter 4 mathematics, which is completing the square method. Students, in this video I am going to teach you about the algorithm to find the square root of any quadratic equation, and simultaneously we will derive quadratic formula, also known as Shreedharacharya formula. So our first step is to make coefficient of x square equal to 1. Say student, our quadratic equation be ax square plus bx plus c equal to 0. And now here when we divide the equation throughout by coefficient of x square, which is a, so we get x square plus b upon ax plus c upon a equal to 0. And now student, our next step is to take the coefficient of x, which is b upon a, and divide this b upon a by 2. So we get b upon 2a. And now student, in the third step, square this b upon 2a. So we get b upon 2a whole square, and write plus b upon 2a whole square and minus b upon 2a whole square in our quadratic equation. As you can see, by taking plus and minus, it will not affect our quadratic equation. So we can write it as x square plus b upon ax plus c upon a plus b upon 2a whole square and minus b upon 2a whole square equal to 0. And now student, as you can see that this x square plus b upon ax and b upon 2a whole square can be written as in the form of binomial expression, which is x plus b upon 2a whole square. And now shift the remaining terms, which is c upon a and minus b upon 2a whole square, to right hand sides. So from here we get x plus b upon 2a whole square equal to b square upon 4a square minus c upon a. Now on taking the LCM in right hand side, we get b square minus 4ac upon 4a square. And now take the square root both sides. So we get x plus b upon 2a equal to plus minus square root of b square minus 4ac upon 4a square. So from here we obtain the value of x, which is equal to minus b upon 2a plus minus square root of b square minus 4ac upon 2a. And student, this is known as quadratic formula or Shreedharacharya formula. Here let d is equal to b square minus 4ac, where student d is known as discriminant. So our quadratic formula will become x is equal to minus b plus minus root d upon 2a. And now based on completing the square method, we will do one question, which is find the square root of equation 5x square minus 6x minus 2 equal to 0 by method of completing the square. So as per our algorithm, first make the coefficient of x square equal to 1. So here coefficient of x square is 5. Now divide the whole equation by 5. We get x square minus 6 upon 5x minus 2 upon 5 equal to 0. And now student, next step is take coefficient of x, which is minus 6 upon 5, and divide it by 2. So we get minus 6 upon 5 into 2, which is 10. So on solving this fraction, we get minus 3 upon 5. And as per algorithm, I have told you that now we write plus minus 3 upon 5 whole square and minus of minus 3 upon 5 whole square equal to 0 in our quadratic equation, as this positive and negative will not affect our quadratic equation. So from here, I can write our quadratic equation as x square minus 6 upon 5x minus 2 upon 5 plus minus 3 upon 5 whole square minus of minus 3 upon 5 whole square equal to 0. And now here, as you can see that x square minus 6 upon 5x and plus and in bracket minus 3 upon 5 whole square can be written as in the form of binomial expression, which is x minus 3 upon 5 whole square. And then we will shift the remaining terms to RHS. So in RHS, we get minus 3 upon 5 whole square and plus 2 upon 5. And now on solving the RHS by taking the LCM, we get x minus 3 upon 5 whole square equal to 19 upon 25. Now from here, on taking the square root both sides, we get x minus 3 upon 5 equal to plus minus root 19 upon 5. So from here, value of x equal to 3 upon 5 plus minus root 19 upon 5. So there are two square roots which we have obtained, x is equal to 3 plus root 19 upon 5 or x equal to 3 minus root 19 upon 5. Now student, based on above method, do this two question mentioned on your screen and share me the solution. So this is the end of this video. Thank you for listening me as always. God bless you all.